Imagine a camera system that doesn't just respond to what it sees, but to what it knows. Not visually, but mathematically. A system that doesn't rely on facial recognition, motion blur calculations, or visual subject tracking. Instead, it works off pure data, coordinates, rotation, velocity, elevation, and direction. That's the idea behind turning numbers into motion. At the heart of this transformation lies a technology called IMU Inertial Measurement Unit. It's in your smartphone, your smartwatch, drones, even in advanced weaponry. It combines accelerometers, gyroscopes, and sometimes magnetometers to calculate orientation, position, and velocity in space. And for the future of filmmaking, it might be the single most powerful underutilized asset. Let's break this down. A wearable device with an embedded IMU constantly emits a stream of real-time data: pitch, yaw, roll, acceleration, and angular velocity. This stream can be translated into relative position. If you're holding a phone in your hand and rotate it 45 degrees to the left, the phone knows that. If you step forward 3 feet, the phone registers the shift in acceleration and velocity. This same logic can be extended to a beacon worn on your chest or shoulder. As you move through space, the IMU knows where you're going and how fast. That data can be sent wirelessly to a camera system running a processing unit either on board via something like a Raspberry Pi or ARM chip or remotely through a phone app. From there, the data is translated into motor instructions. That's the connection. Data in gives motion out. You might be asking, why IMU over GPS or ultra-wideband? GPS is great outdoors, but it lacks precision indoors, often drifting by 1 to 3 meters, which is unacceptable for cinematic framing. Ultra-wideband UWB is incredibly precise down to 10 centimeters, but requires a built infrastructure of anchors or a tightly controlled environment. IMU, however, is completely self-contained. It doesn't need satellites or beacons. It's instantaneous. It does drift over time, but when combined with occasional positional corrections, say, via visual cues or limited GPS updates, it becomes stable and reliable. And it's fast. That's why it's used in drones. It reacts immediately. Now let's explore how this works in practice. Say an actor is walking toward the camera. They're wearing the IMU beacon. The system registers their forward velocity and calculates they'll be at 8 feet into seconds. It sends that info to the focus motor, which pre-adjusts the lens so that they remain in perfect focus. Simultaneously, the gimbal tilts to maintain eye-line composition and zooms slightly for a dramatic push-in. All of this happens without human touch. You didn't press record. You didn't adjust the shot. You just moved and the system responded. This setup allows for programmable shot types. You could set the system to automatically lock into a cowboy shot once the subject is 15 feet away, or switch to a close-up at 6 feet. The logic is all numerical. Focal length plus subject distance equals field of view. That's how we turn numbers into visual language. What makes this revolutionary isn't the tech, it's the orchestration. We're not inventing zoom motors, follow focuses, IMUs, or gimbals. We're connecting them. We're teaching them to speak the same language, one built on spatial intelligence and AI prediction. The result is a camera system that not only follows you, but frames you, understands you, and anticipates what you need. It's like giving the camera a brain and letting that brain think in distance, velocity, and lens geometry. This is the core of turning numbers into motion. It's not about automation for the sake of novelty. It's about giving creators the ability to shoot scenes with the depth and polish of a full crew while standing alone. It's about liberating the visual process from technical constraints. And it starts by asking, what if the shot didn't depend on a human hand but on a mathematical mind? The camera doesn't need to visually lock onto you. It doesn't need to see your face. It simply receives your coordinates in real time. Those coordinates tell the gimbal, rotate 11 right, elevate 4, pawn back to per second. This is how drones follow subjects through forests or cities. But instead of aerial cinematography, we bring that same technology to the ground with a mounted camera that knows exactly where you are in 3D space. Now, let's talk about hardware. To build this system today, we don't need to invent every piece. The parts already exist, we just need to sync them. A variable zoom lens is one key piece. That's a lens that can zoom in and out smoothly during a shot. Add a wireless follow-focus motor, the kind already used in professional productions, which can electronically adjust focus and zoom based on input signals. Attach that to a gimbal capable of smooth motion, something like a DJI Ronin or Zhiyun Crane, and we now have a moving platform. The final piece. An interface, like an app, that interprets incoming IMU data and sends real-time commands to those motors. It tells the gimbal where to move, tells the lens how to zoom, and tells the follow focus where to lock.